This is what scientists are telling us, that our planet is traveling through the debris field of an ancient supernova. Radioactive dust deep beneath the ocean waves suggest that our Earth is moving through a massive cloud left behind by an exploded star. Continuously for the last 33,000 years, space has been seeding Earth with a rare isotope of iron forged in supernovas. It's not the first time that the isotope known as iron-60 has dusted our planet, but it does contribute to a growing body of evidence that such dusting is ongoing, and we're still moving through an interstellar cloud of dust that could have originated from a supernova millions of years ago. Iron-60 has been the focus of several studies over the years. It has a half-life of 2.6 million years, which means it completely decays after 15 million years. So any samples found here on Earth must have been deposited from elsewhere, since there's no way any iron-60 could have survived from the formation of the planet 4.6 billion years ago. Kindly support my Patreon account, since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below. And deposits have been found. Nuclear physicist Anton Wallner of the Australian National University previously dated seabed deposits back to 2.6 million and 6 million years ago, suggesting that debris from supernovas had rained down on our planet at these times, 2.6 million and 6 million years ago. But there's more evidence, recent evidence of this stardust, much more recent. It's been found on the Antarctic snow. According to the evidence, it had to have fallen in the last 20 years. And a few years ago, scientists announced that iron-60 had been detected in the space around Earth, measuring over a 17-year period by NASA's space-based Advanced Composition Explorer. In 2020, Wallner found more of the stuff in 5 samples of deep sea sediments from 2 locations dating back to 33,000 years ago, and the amounts of iron-60 in the samples are pretty consistent over the entire time period, but this finding actually poses more questions than it answers. Earth, you see, is currently moving through a region called the Local Interstellar Cloud. It's made up of gas, dust, and plasma. If this cloud was created by exploding stars, then it's reasonable to expect that it's dusting Earth with a very fine rain of iron-60. This is what the Antarctic detection suggested, and this is what Wallner and his team were seeking to validate by examining the ocean sediments. But the Local Interstellar Cloud is a source of the iron-60. If it is, there should have been a sharp increase in the solar system when our solar system entered the cloud, which according to the data from the team is likely to have occurred within the last 33,000 years. At the very least, the oldest sample should have had significantly lower levels of iron-60, but it did not. It's possible, the researchers note in their paper, that the Local Interstellar Cloud and the supernova debris are coincident rather than one structure, but the debris remains in the interstellar medium from supernova that took place millions of years ago, and that would suggest that the Local Interstellar Cloud is not a faint supernova remnant. Wallner said last year, there are recent papers that suggest iron-60 trapped in dust particles might bounce around the interstellar medium, so the iron-60 could originate from even older supernova explosions, and what we measure is some kind of an echo, he said. The best way to find out, the researcher said, is to look for more iron-60 covering the gap between 40,000 years and around a million years ago. If the iron-60 abundance grows greater farther back in time, that would suggest ancient supernovas. But a greater abundance more recently would suggest that the Local Interstellar Cloud is the source of the iron-60. This was published in Proceedings of the National Academy of Science. It's on Science Alert. Please leave your comments, and thank you for your support.